So today we're just going to do this part right here, the arc length part. So there's this formula right here. Now, this is the formula for arc length right here. And the way that you think about this is think of x as being r cosine theta and y as being r sine theta. Think of those as parametric equations. And then you start with this right here. You have from A to B. If this were in T, for example, okay? So think of theta as being your angles right here. It's theta going from A to B. So then what would this would tell you that the arc length is going to be this. It's going to be the square root of dx d theta squared plus dy d theta d theta. Okay, and this is just from the formula for if you have parametric equations. And so then what you would do is, at this point is you would calculate dx d theta first. And x is r cosine theta, but you have r is going to be your function, of course, f of theta. So r is a function of theta, okay? So dx d theta will be you use the product rule. So that would be r times the derivative of cosine, which is going to be negative r sine theta, plus the derivative of the r part, which is dr d theta, times the cosine theta. And then the same thing, dy d theta, or similarly, dy d theta will be your r times the derivative of sine, which is cosine, plus dr d theta, sine theta. Okay, now when you put all this into this equation, then you're going to get all of this squared plus all of that squared. And then you still have the d theta outside. So all I'm doing is just calculating these derivatives and plugging them into here. Now, when you square this out, what happens? You're going to get this squared, which is going to be r squared sine squared theta, plus the product of those two, which is minus, the product is going to be minus 2. Okay, you double the product, so that's 2, and then you have an r dr d theta, and then you have sine theta, and you have cosine theta. Okay, then you plus this last one squared, which is dr d theta squared cosine squared theta. Okay, that's just the first term. Now you have the second term right here, which I will do in this purple color. So this one squared, that's r squared cosine squared theta, plus double you take the product and double it, so that's 2r dr d theta cosine theta sine theta, and then this one squared. Okay, so dr d theta squared sine squared theta. Okay. Okay, so what happens at this point is this term and this term will cancel because they're just negatives of each other. I mean, the sine and the cosine are just reversed. That's the only thing with this, both same thing. And then also, if you look at, say, this one and this one, that is equal to r squared times sine squared plus cosine squared, right? And you know that sine squared plus cosine squared is 1. So this is just going to be r squared. Okay, so those two terms are just r squared. And then these last two terms, that one and that one, they just add up to drd theta squared, because cosine squared is sine squared is 1. Okay, so you just take those two terms, group them together, factor the drd theta squared out, and then you're left with cosine squared plus sine squared is the other one, which is just 1. So that's just this times 1, and that's just, this one's just this r squared times 1 as well. Okay, and of course that is this equation here. Okay, so that's how this equation is derived, and that's how you find the arc length. Okay, so let's just do this very last exercise is dealing with that. So go back to the very number 7, which is the last exercise of the section, the arc length. Okay, so what the arc length said was it's going to be the integral from a to b of the square root of r squared plus drd theta squared d theta. And here's our r right here. Okay, so we have to figure out a few things, like we have to figure out these limits of integration. We have to figure out what drd theta is. R is just this, so that was just, so this is just going to go into here. So let's get to work here. First of all, drd theta. Okay, so you think of this as cosine of theta over 2 quantity squared. Okay, you think of it like this. And so when you take the derivative, it's the power rule. This 2 comes down, and then you multiply the derivative inside. Now the derivative of this is going to be negative sine of theta over 2. So your answer is going to be negative. When you have a 2 coming out, reduce this by 1, so you have just cosine of theta over 2, times the derivative of this, which that's where the negative comes in, which is going to be sine of theta over 2. But you'll also have by the chain rule, you'll have the derivative of theta over 2, which is 1/2. So you have a 2 coming out right there. Okay. Okay. So drd theta is this, or negative cosine theta over 2, sine of theta over 2, like that. Now we have to figure out what the limits of integration are going to be. And a lot of times when you have paths like these, they cross over themselves, and so that's kind of and it starts to retrace itself. Okay, and so the limits are not always from 0 to 2 pi. But here, because this is always positive, let me just make a note of, let me just remark on that. Cosine squared is always positive. Okay, so what that means is when you have the graph of it, okay, so when theta is 0, you're going to be out at 1, right? When the graph is never going to, it's always going to be positive values of r. So that means as you go along here, this is never going to hit the origin and then go through it. I mean, it'll hit it maybe at when theta is equal to pi, it'll probably hit it there, which means you get a pi over 2. But then instead of going negative and then like retracing and possibly retracing anything, it goes back to positive or something like, so it's going to be something like that. Okay. And wait a minute, this is 2 pi, this is, yeah, so when theta is 2 pi, this is cosine of pi. Okay, when theta is 2 pi, this is pi, so it's cosine of pi, which is -1, but when you square it, you get 1, so it comes back to that. So well, this looks like a kind of a heart. Okay, this is squared, so it's kind of not a cardioid, but yeah. Okay, so let's see here. So this means that we can go ahead and continue on. We know that the limits of integration are going to go from 0 to 2 pi. Okay, just by what I said here, it's always positive. If you go more than this, then you start retracing what you've already done, and so that doesn't really give you the length of the curve. Okay, so we put r squared. Now r is this, so plug this in, and we're going to square it. So it's cosine squared of theta over 2, and now that's all squared. Now you could put, if you want, you could just put a cosine to the 4th in there, that's fine. It's too late for me because I have to erase a whole bunch of stuff to do that. Okay, then drd theta, here's drd theta, and that's squared also, so that will, so your negative sign will get dropped. And then I can just square each of these individually like that. Okay, then what I'm going to do next is I'm going to, out of this expression that's inside the radical, I'm going to factor a cosine squared out. And when I do that, I have a cosine squared theta over 2 from here, and I have a sine squared theta. No, plus sine squared theta over 2. And that's pretty convenient because now this right here, that just reduces to, it just reduces to 1. Okay, so you can just like ignore it. So we have this right here. The square root of cosine squared of theta over 2. Now, you might be tempted to just drop the radical because after all, radical and square root kind of cancel each other out. But really what happens is you get the absolute value of cosine of theta over 2. Because we did discuss that when theta becomes, wait a minute. When theta becomes more than pi, then you have pi, so like, for example, pi over 2, when you put a pi over 2 in here, it's negative, right? But when you're more than pi, so to say a little bit more than pi, then you're taking the cosine of a number that's a little bit more than pi over 2, okay? Which is going to, the cosine is the x value over the hypotenuse, okay? And the x values are negative, so that's going to be negative. So essentially, what this means is that from 0 to, so let me summarize. I'll try to summarize what I just said. Hopefully, it will be understood. From 0 to pi, the absolute value of cosine of, is just cosine of theta over 2. But from pi to 2 pi, it is negative. Because when you have, we put values in here that are between pi and 2 pi, cosine is negative. It's this will be a negative number. So I put this negative here to force it to be the absolute value. It forces it to be positive. Okay, and so this is going to be the answer. If you just integrate from 0 to 2 pi without the absolute values, you're going to get 0, and then you'll be like, and then you should immediately think, well, I can't have an arc length that's 0 because we know that it's actually a curve here. That can't be 0. Okay, so that's, you know, that's another thing, another red flag. There's also this, like, if you were to get a negative value for arc length, you can't do that. You can't be negative. Okay, so doing this one, you integrate, and that gives you, what's that, sine, or negative sine of theta over 2 from 0 to pi. And then right here, this is going to be positive sine of theta over 2 from pi to 2 pi. And then I plug in the limit. So I plug in the upper, wait a minute, what am I doing? No, this is positive. I got things a little bit backwards because it's Monday. So on Monday, I'm allowed to do that. Okay, so the integral is just sine of theta over 2. Oh, times 2. Well, I got things already bad, way backwards. Okay, so there's a 2 right there. And because when I take the derivative here, it becomes sine. I mean, the derivative of sine is cosine. But then the derivative of this is 1/2. So I have a 1/2 coming out. I need a 2 there to, so that when this 1/2 comes out, the 2 takes care of it, and you'll just get this. Likewise, this one. Okay, so we put a pi in first. So that's going to be 2 sine of pi over 2. And then subtract and put 0 in, 2 sine 0. And that's 0. Okay, now I put in the 2 pi here. That's minus 2 sine. If I put 2 pi in here, I get pi. And then subtract, but that's actually plus 2 sine of pi over 2. And then these are both going to be 0. And this is 1, and that's 1. So the answer is 2 plus 2, or 4. 4 should be the answer. So that should give you the answer for that exercise. Any questions about this or about anything from section 10.4A? Okay, great. Let's go ahead and save that. We'll go on to 10.5. Okay, 10.5 was about conic sections. And let me see here. Let me go into something as to why they're called conic sections, okay? So there's a program that I like. It's called Tinkercad. Are any of you guys familiar with Tinkercad?
No.
No? Okay. Let me just bring it up here and show you. You don't have to, it's not necessary. But I just wanted to show you what about conic sections. And conic sections, first of all, conic sections are, there's 3 different types. There are parabolas, which is this one right here. And those are the formulas that I use to work with parabolas. And then, oh, I didn't change the date. Oops. This is March 1st, right? It's not leap year, it's March 1st. Oh, I did change the date, but I got it wrong. Okay, then there are these equations right here, which deal with ellipses. And a circle is an example of an ellipse, by the way. And then there's these equations right here, which are hyperbolas. Okay, and so the difference between the ellipses and the hyperbolas is that the ellipses are pluses, but the x squared and the y squared are both, the x's and the y are both, x's and y's are both squared, and it's equal to 1. And the hyperbolas, those are minuses right here. This is a minus, that's a minus, okay? Okay, so I wanted to do a little thing in Tinkercad just to show you what this looks like there. So, but it'll take me, hold on a second, it'll take me a while to get to it. Tinkercad.com. Okay, so I have a, oh dang, I'm not logged in. Oh, I have a Tinkercad account. It's just online. It's for 3D printing. So I do some 3D printing, and so I use this to do 3D printing. Like for example, we did these D20 dice. If you want one of these, yeah, I can give you one of these if you come to my office. They're really cool. Anyways, I have a demonstration on conic sections. So what it is these are cones, right? That I have different cones here, and so there's like a cone like that, and then there's another cone. It's inverted, and they touch at the top here. Okay, and these are where conic sections can come from. Like if you take the middle one, what I've done is I've constructed these cones like this, and then I have this plane right here. This dark plane that slices through the cone. okay? And if you look at the boundary of where it slices through, that is an ellipse. Okay, so in that case, you're going to get an ellipse. Okay, now if I look at, I've sliced through this cone right here, this blue one, and the boundary with a plane, and the boundary on the cone here, guess what that is? That's a parabola. Okay, the boundary on the cone where this slices through, that's a parabola. Okay, over this green one, I've sliced through with a horizontal plane, and that's going to be a circle, which is a special case of an ellipse. Okay, this red one here, I took a plane and I sliced it through vertical to the cones. Okay, it just slices through vertically, and that is a hyperbola. The intersection with the boundary of the cones is a hyperbola of the plane, and the boundary cones of a hyperbola. And then of course here I have the purple one again is an ellipse. Okay, so that's kind of where the conic sections come from. Okay. So let's see. Let's go back to the conic sections. Okay, these are different formulas that I use. Now, for the parabola, okay, what parabolas are? Now what I just showed you with the cones and everything is not really. It's kind of weird because they're called conic sections, and it's because you can like match it up with the cones and all that. But in reality, when we do the calculations, you don't really have to know that they're intersections with planes and then these cone things. Okay, and that doesn't even help you to do the exercises any better. Okay, it's just I thought it's kind of interesting to just show you why they're called conic sections. And it doesn't really help you with the homework or anything, but yeah. Okay, so parabolas, another way of thinking about parabolas is that they are the set of points equidistant from a point, okay, which is called the focus, and a line, which is called the directrix. Okay, so they're the set of points that are equidistant from a point, which is the focus, and a line, which is called the directrix. Okay, let me show you with an exercise. That's probably best to show you with an exercise here. So, so here we have the equation of a parabola right here. And what you want to do is, if we go back to the first page, we wanted to get it in the form of either x squared equals something times y, or y squared equals something times x, okay, whichever one it is. And this one is x squared, so you should be able to solve this for x squared. So I take the 12y to the other side of the equation, and then I divide by 5, and I have negative 12/5 y. And so that's what I have. Now, most of you might be familiar with, but most of the time you're familiar with the parabolas as being something like this: y minus k equals a times x minus h squared, like that. Okay, and these are parabolas where the y is not squared, then the x thing is squared. And this is going to go open up if a is greater than 0, and it'll open down if a is less than 0. Okay, so a greater than 0 opens up and a less than 0 opens down. Now we could take this one right here, and we could put it in this form, and then since there's a negative there, then we know that it opens down. Okay, so this red thing right there is not in the same form as this. It's not. But if we were to put it in that form by solving for y, then because that's negative, this negative would go over here, and this a would be negative. So it would open down. Okay, so it's got to be this one right here. It's got to be the parabola that opens down at that point. Now, the vertex is going to be, okay, the vertex in this one is going to be h comma k. Okay, but here we don't. They're going to be 0. So this x squared is the same as x minus 0 squared, and this y is the same as y minus 0. So the vertex is going to be 0, 0 in this case. Okay, now the focus and the directrix. Okay, this kind of form doesn't really give you where the focus is. Okay, but the way that I have this p right here is the key to the focus, to finding the focus and to finding the directrix. Okay, so we have it in. So what we need to do is find out what that value p is. And once we find that, then I'll show you how to find finding the focus and the directrix is. I'll show you that. So first of all, you need to find the p. So we're in this form right here. Okay, so from the first page, x squared equals 4py. That was from the first. That was one of the formulas on the first page. And so what you do is you equate this and that. So 4p equals negative 12 over 5. Okay, divide both sides by 4, and you get negative 3 over 5. Okay. Okay, so p is negative 3 over 5. Now, looking at the graph, since it opens down and the vertex is right here, you go down by 3 over 5. Okay, so 0, 0. Okay, you go down 3/5. That is going to get you to 0, negative 3/5. And this will be the focus. Okay, hold on a second. I got the wrong assignment. Okay, so 0, negative 3/5. And then you're going to go the opposite direction for the directrix. In this case, it'll be y equals positive 3/5. Okay, so let's consider this right here. So I said the focus is right there at negative 3/5, and the directrix is y equals 3/5, which is this right here. Now, if you take any point right here on the parabola, you look at that distance and that distance, those are going to be the same. Okay, those distances are going to be the same. Okay, or let's say this point right here, for example, that's like halfway between these two. Well, I've probably drawn the green point a little bit lower than it should be. Okay, but you take other points, like so say that point there, then that distance and that distance are supposed to be the same. Okay, so that's how that works. Okay, any questions about that one? Okay, let me go a little bit different. The next one. Now, some of these you're going to have to complete the square, like this one right here. So here I have y squared. What the? Okay, so y squared plus 6y. Now I'll take this 3x over to the other side, so that's negative 3x. I'll also take this negative 6 over there. Okay, so I have my square term on the left, and I have my non-square term on the right. And what I'm going to do here is complete the square by adding a 9 there. But then the other side's going to get really angry at me if I don't add a 9 to that one. So I'll add 9 over there. Okay, and then this allows me to, this gives me y plus 3, not y plus y plus 3 squared equals, what is this? This reduces to, these combined to give you plus 3. And then if I factor a negative 3 out, I get x minus 1. Okay, now to find the vertex, what I'm going to do, all I do is I look for what value of x will make this 0, and the answer is 1, and what value of y will make this 0, and the answer is negative 3. Okay, so the vertex will be 1, negative 3. Okay, now for the focus, again, I'm going to look at x squared equal, or actually I have a y squared, right? Oh yeah, I've got the squares on the y, so, but it's still, there's a 4p right there, okay? So the key is taking this 4p and setting it equal to this piece right here, negative 3. Okay, so that gives me p as negative 3/4. Okay, now because the square is on the y, then it's either going to open to the left or to the right, and because this is negative, it's going to open to the left. Okay, because this is negative, it'll open to the left. If this were positive, it would open to the right because the square is on the y. So this is the only one that it could be. And since it opens left, then the focus will be 3/4 to the left of the vertex, okay? So for the focus, I start with the vertex, and I go to the left by 3. So that'll be 1 minus 3/4, 3. And so that will be 1/4, comma, negative 3. Wait a minute. Yeah, 1/4, comma, negative 3. That's interesting. So that's the focus. Okay, then the directrix will be the opposite direction. So instead of subtracting 3/4, I add 3/4 to 1. And that gives me 7/4. And because it's a vertical line, then it's x equals 7/4. Okay. Any questions about that? Okay, let's go on to the next exercise, number 3. Here we have a graph right here, and we're just supposed to figure out the formula for it. And here, I guess here it doesn't really matter what you put the form in. How you put that. I don't think it really matters how you put the form. You could put it in, well, let's put it in the form that they want though, okay? So, but we can start off, maybe the best thing is to start off with something that we're familiar with. This opens up, right? So So we're going to end up with y minus h equals a times x minus k squared. Okay, or I guess if we're going to go with the form that they have on the first page, since it opens up, then then it's going to be this right here. The square is going to be on the x. Okay. So I like to write it as x minus h squared equals, we'll just put an a there for now, a times y minus k. Okay. And from the graph, we can tell that the vertex is at 2, -2. The x component is 2. Okay, so that's our h. And our y component is -2. So k is -2. So we can put those values into here. And that gives us x minus 2 squared equals a times y minus k. Y plus 2. Y minus a -2, which is y plus 2. Okay, now we also know that it goes through the point 0, 0 right here. That's on the graph. That means that it will have to start, if I put zeros in for x and y, so if I put 0 in for x and a 0 in for y, then this should still satisfy, then the equation should work out. So over here I get 4, and this is 2a. So that means that our a is 2. Okay, so and that would be the equation of the parabola. Okay, so that should work right there. Now for the focus, again, 4p is going to be 2, which means p is going to be 1/2. Since it opens up, then our focus will be 1/2 point above the vertex. Which brings us to 2, -3/2. And the directrix will be in the opposite direction. So you start with the vertex and you go down. So that's -5/2. Okay, so y equals -5/2 because it's a horizontal line down here. So the vertex is right there, directrix down there. Okay, any questions about this? Okay, so parabolas are looking pretty good. Let's do ellipses. Talk a little bit about ellipses. Okay, now the A determines where, or I'm sorry, the C determines where the foci are. Okay. So, and the C is the distance from the focus, from the center, where it's centered at, to where the focus is. Okay, so, and ellipses, let's say a little bit about ellipses. Okay, so the ellipses is a set of points whose sum of the distances to the foci, or that's plural for focuses, focus, is constant. Okay, so maybe the constant is 5, maybe it's 7 or whatever, okay? And essentially, the way that it works is you have two foci, two focuses, and I don't know, this is probably really bad, but the way that it works is if you take, let's say you have a point right here, if you take that distance plus that distance, then that's supposed to be the same as if you had like that distance and that. Well, this is really bad. This is not, I didn't draw it very well. Oops. Hold on. Let me try to draw a better one. Here the focuses are going to have to be out further towards the extremes. Maybe that works, maybe not. So essentially, if you any point on the vertex, on the ellipse, you'll have two distances. You'll have this distance and that distance. So here I have that distance and this distance. Okay, now the sum of the two red distances has to equal the sum of the two green distances. Okay, so the red sum equals the green sum. Okay, and then if you have, oops, what is this? And then if you have like, you could have a different, you know, and so on. So like if you had maybe you're taking that distance here and that distance equals the purple sum. Okay, so the sum of those two distances is the same. Okay, and this is a kind of interesting concept, and it has practical applications. Like for example, the tabernacle in the old tabernacle in Salt Lake City, that this is three-dimensional. So the ceiling is an ellipsoid, and one of the focuses is at the pulpit, and the other focus is down in the audience. And so they typically do like a demonstration. Maybe some of you have been there or you heard about it, where they'll drop a pin at the pulpit, and then they'll have a bunch of people sitting over at the other focus, and the sound waves, okay, so if this is the pulpit right here, the sound waves go out and hit the ceiling or whatever, and they bounce off the ceiling, and then they arrive at the same exact time at the other focus. And so it's as if you're like right at the pulpit. So you can hear really soft noises from the other one, because the sound waves travel they arrive at the same time. All of them arrive at the same time. That bounce off the ceiling arrive at the same time. So that's how that works. And then another application is they use this idea to pulverize kidney stones. So someone will have a kidney stone, they'll do something, they'll give them some kind of a drug to identify so they can tell where the kidney stones are. They'll put them in a tank that's of water, submerge them in water. They'll position them so that the kidney stone is at one of the foci. At the other foci, they'll have like a pulse generator that will generate a force. Okay, it will generate a shock wave. The shock wave bounces off of the tank sides, which are in the form of an ellipsoid, and they arrive at the same time. And hopefully, and the idea is that they'll pulverize the kidney stone, and that works a lot of the time too when they do that. And so that's how they can break up kidney stones. Okay, so that's just an application of ellipses and how that works. Although when we're doing calculations on doing all this stuff, it doesn't necessarily help us that much to know that. Okay, but if you want to be able to construct something that's in the form of an ellipse, then that does help to know these equations. Okay, so the C determines where the focus is. So let me just do one exercise using an ellipse. Okay, so here we have, oh good, I've got the equations here again. And I want to put it in this form, so where it's equal to 1. So I divide everything by 9. So by the way, 9 is 3 squared. So I can go ahead and just go ahead and change that 9 to a 3 squared. And of course, if I divide by 9, then that's just going to be 1. So I can have a 1 squared there equals 1. If I don't have anything, then it's just going to be 1 squared. So I'm just going to write like that. That's kind of weird, but yeah, let's just leave it like that for now. And so you look and see which is larger. The 3 is larger than the 1. So that means that in this case, we're this one right here. 3 is greater than 1. This 3 is greater than 1. So then the A is below the X and the B is below the Y in this case. So we're like this. Okay. Now the center is going to be 0, 0. So once again, the generalization of this would be like if you had X minus H squared over A squared plus Y minus K, squared over B squared equals 1. That would be the generalization to these. Okay, so for the vertices, well, to graph the ellipse, what's going to happen is this is 3 plus or minus 3 in the X direction. And plus or minus 1 in the Y direction. Okay, so you might have seen like this. And this is roughly how the ellipse is going to look. Although I did kind of distort that a bit. So it's going to be this, it's going to be this one here. Because this is 3, right? And negative 3. So it's going to be that one. And the vertices are the ones that lie along the major axis. Okay. So these 2 points are the vertices. This is the major axis. This is the minor axis. The vertices are going to be the ones on the, and this one says smaller X values. That'll be, we'll lead out with that one, negative 3, 0. And larger X value is 3, 0. Okay, for the foci or the focuses, you use this equation to get them. Okay, so that's going to be 9 minus 1, which is 8. So C, that's C squared. So C is going to be plus or minus the square root of 8, which is 2 root 2. Okay, so what that means is your foci are going to be here and here, where this is 2 root 2, and this is negative 2 root 2. Okay, so negative 2 root 2, 0, and 2 root 2, 0.